Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The heat released per CH2 unit in the hydrogenation of cycloalkanes is directly related to the ring strain energy of the cycloalkane. More strained rings have higher potential energy, and upon hydrogenation, ring opening plus H2 addition, they release more energy. Moving on to the next step. Recall ring strain energies of cycloalkanes. Cyclopropane, 3-membered ring very high ring strain, (115 kJ mol total, (38.3 kJ mol per CH2). Cyclobutane, 4-membered ring high ring strain, (110 kJ mol total, (27.5 kJ mol per CH2). Cyclopentane, 5-membered ring low ring strain, (26 kJ mol total, (5.2 kJ mol per CH2). Cyclohexane, 6-membered ring essentially no ring strain, (0 kJ mol, (0 kJ mol per CH2). Moving on to the next step. The heat of hydrogenation per CH2 unit correlates with ring strain per CH2 unit. Cyclopropane has the greatest ring strain per CH2 unit because the CCC bond angles are compressed to 60 degrees, far from the ideal tetrahedral 109.5 degrees, creating maximum angle strain plus torsional strain. And for the final step. When cyclopropane undergoes hydrogenation to give propane, the ring strain energy is fully released as heat. Dividing by the number of CH2 units, 3 for cyclopropane, cyclopropane releases the most heat per CH2 unit. Cyclobutane has less ring strain per CH2 than cyclopropane. Cyclopentane has very little ring strain, releasing minimal heat per CH2. Cyclohexane is essentially strain-free, chair conformation, so it releases the least heat per CH2 unit. Conclusion: cyclopropane plus H2 propane releases the maximum heat per CH2 unit due to the greatest ring strain per CH2. Therefore, the correct answer is A. Therefore, the correct answer is option A.